Hi everyone, let's be brave and find the domain of G here, where G of t equals the square root of 3t plus 9 all over 2t squared plus 20t. Remember, it's not always f of x. Here we have G of t. So when does this yield a real output? How do we keep it real? All right, G of t is real if and only if what two things are true? Well, notice here we have a square root on top. So what do we need to be true of the radicand, 3t plus 9? To keep it real, we only take the square root of what kind of value? Non-negative. And furthermore, the denominator, 2t squared plus 20t, cannot be what? In order to keep it real, the denominator, 2t squared plus 20t, cannot be 0. So G of t is real if and only if this is true and this is true. We can only take square roots of non-negative values, and we never divide by 0. Let's solve this inequality first. Let's solve 3t plus 9 is at least 0. We can subtract 9 from both sides. We get 3t is greater than or equal to negative 9. Remember, you do not flip the symbol if you just subtract. We divide by positive 3. Again, that does not flip the symbol. T is greater than or equal to negative 3. So we have this as a condition. G of t is real if and only if, basically, t is greater than or equal to negative 3. And, again, if this thing here is not 0. Okay. So we need 2t squared plus 20t to not be 0. Now here, I deal with inequations, but instead I'm going to go ahead and think in terms of equations. But remember, we want to avoid the following. We want to avoid a 0 denominator. So we want to avoid 2t squared plus 20t equaling 0. This is what we want to avoid. But at this point, it's a matter of solving the equation. Let's start by factoring out the GCF. The GCF is 2t over here, 2t. When you factor, you divide. We get this other factor here, t plus 10. So this factors as 2t times the quantity, t plus 10. And then we apply the 0 factor property. So when does this product equal 0? If 2 equals 0, or t equals 0, I could probably type these out. If 2 equals 0, or t equals 0, or t plus 10 equals 0. Well, 2 never equals 0. I can zap that. That's a dead end. Okay? Or t equals 0, or subtract 10 from both sides. T equals negative 10. So is that the domain? T equals 0, t equals negative 10? No, 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 no. These are the bad guys. These are the bad guys. We have to avoid t equals 0 or t equals negative 10. Okay, so what's the negation of this? The negation. The negation is t cannot be 0 and t cannot be negative 10. Of course, you're wondering, why are we going from or to and? That's a logical rule called De Morgan's laws. It's a set of rules. Basically, De Morgan's laws say that the negation of an or expression is an and expression, and vice versa. So for example, what does it mean to not be an American? Well, what does it mean to be an American? It means that you're an Alabaman, or an Alaskan, or an Arizonan, or so forth. But wait a minute. That means that you're not an Alabaman, and you're, I'll put this in red. You're not an you're not an Alabaman, and you're not an Alaskan, and you're not an Arizonan, and so forth. You're not this, and you're not that, and you're not that, and you're not that. The negation of an or expression is an and expression. You're not an Alabaman, and not an Alaskan, and not an Arizona, etc. So here, the negation of an or expression is an and expression, together with what we had up here. So let's collect all of our restrictions. T has to be greater than or equal to -3, and T cannot be 0, and T cannot be -10. But now wait a minute, this might be overkill. This might be overkill, because take a look here. Consider the real number line. All right, it's a T number line. From this top here, we want -3 for now, and we want all greater values. That's based on this inequality over here. But T cannot be 0. So that means we have a hole at 0. We want to skip over the 0. And a hole at -10. But wait a minute. -10, that's already out. That's already out. That's not in this purple shaded region anyway, right? -10 is not at least -3. So -10 was dead meat anyway. I'll put it this way over here. -10 was dead meat anyway, because -10 is not greater than or equal to -3. So this is really superfluous. It's redundant. We don't need this if we already have that. So really, we just need these two conditions. In set builder form, the set of all t's in the reals, such that t is greater than or equal to -3, and t is not 0. On the graph, we start with -3. That's a solid endpoint. We want greater values as well, but we skip over the 0. We don't want the 0, so we put a pothole there. We skip over the 0, and we get this right wing over here. What's this in interval form? I'll give you 10 seconds. It helps a lot to do the graph before you write down the interval form. Well, we include the -3, so bracket, -3, comma, 0, parenthesis, we skip over the 0, union, parenthesis, 0, comma, infinity, parenthesis. We skip over the 0, we have parentheses around the zeros. All right, so this is the domain of this function g, the set of all real values for t for which this output is real, and only those values. Next up, how you evaluate functions.